Hello everyone, and welcome to our online pre-calculus class. This is class number 1, and today we'll cover sections 1.1 and 2.1 from the book. We'll do a review of function notation, and we'll begin with course introductions. This document right here I call the syllabus calendar, and it's an important document, so let's make sure everybody knows how to access it. So if you log into Moodle, you'll see a list of the courses that you're taking. Click on our course. And at the bottom of this very first box is the syllabus calendar. So that's going to live there the whole semester. There's lots of information in the syllabus calendar. So I made a video on navigating our syllabus calendar, so check that out when you have some time. Okay, next thing to do is take a look at our class notes. I mentioned this is class number 1. This document is also very important for us. This is the one we're going to be working with today. So let's make sure everybody can find this document. So again, it's in Moodle. You're going to have to scroll down just a little bit until you find the box that says material for the first test. And then files for class number 1. And inside of here, we'll see a Word document and a PDF. They're both the same, so print out whichever one is better for you. So this is the document you should have in front of you. You should also have a pen or a pencil in your hand and a calculator nearby. If you can't print this document right now, you should at least have some blank paper in front of you. If you don't have these resources with you right now, pause the video and go get them and come back. Throughout these videos, I'm going to tell you to pause the video to solve some problem. You should do this. The best way to learn math is to do math. Mathematics is not a spectator sport, so be an active learner. I would hope that if you were at a face-to-face class, you wouldn't be texting or emailing or on the phone right now. You wouldn't be watching TV or listening to music. I suggest you put all of those distractions away whenever you are watching these videos. One final note. I will be going much more quickly in these videos than I would in a face-to-face class because you, as the viewer, have the ability to rewind this video in case you need to hear me say something again, or pause the video if you need some time to process what I just said. Take advantage of your ability to pause and rewind. With all that behind us, let's do some math. We begin with number 1. Here's our first activity. It's from an article in the April 1999 edition of the Mathematics Teacher by William L. Blubaugh and Kristen Emmons. Popcorn. George and his family were watching a movie and eating popcorn. Each family member started off with a bowl with the same amount of popcorn. The graphs below all show the amount of popcorn remaining in the person's bowl over a period of time. Under each graph, write a few sentences describing what may have happened. There are 4 graphs down below. Pause the video here, write those sentences, and come back when you're done. Okay, so hopefully you paused the video and wrote in your answers. If you didn't, please pause the video now. You really need to be active in this class if you want to get the most out of it. So let's see how we did. Here in blue, I say that George ate at a constant rate until the popcorn was gone. And I've highlighted in yellow the word gone, and I've also highlighted in yellow 1 moment in time. And so I just want to point out that we know that George's popcorn was gone because that right there is an intercept, and that's the moment when there's 0 popcorn remaining. Taking a look at George's sister, she ate at a variable rate. You can see that she ate very slowly, hardly anything there, but then ate at a pretty good clip here, but then ate very slowly here, and then dramatic turn there. So a variable rate, but still had some popcorn left over at the end, and so I've highlighted that blank space right in here, telling me that she had popcorn left over at the end of the movie. George's dad ate at a constant rate, then stopped eating for a while, and then ate at a constant rate until the popcorn was gone. So there's the constant rate, and then highlighted here in green, we know that George's dad didn't eat any popcorn then, and then eventually the popcorn was gone, same as with George. You could observe when George's popcorn was gone compared to when George's dad's popcorn is gone. And you might ask yourself who finished their popcorn first. Okay, and then finally George's mom didn't have any popcorn for some time at the beginning of the movie. And then she ate at a constant rate for a while before stopping with lots of popcorn remaining. So let's take a look at her graph. So there's a blank space here in the beginning. It's easy to miss, but that means that George's mom didn't have access to the popcorn for a while, and then ate at a constant rate, and then stopped eating and had lots of popcorn left over at the end of the movie. So lots of variations on these themes are fine. You don't have to have them word for word, but the idea here is to kind of warm up and analyze these graphs. Next page. What is precalculus? Our fundamental goal is preparing students to take calculus. What will this course cover? We will start with a review of many of the types of functions you saw in 107. That's the previous math class here at GCC, focusing on increasing our proficiency with exponential and logarithmic functions. Then we'll spend a lot of time working with trigonometry. Why is trig important? So that we can work with triangles, circles, and periodic phenomena. We'll finish up the semester talking about parametric equations, vectors, and conic sections. Some notes on this book. It emphasizes reading and conceptual understanding, not rote learning. Most homework problems aren't just problems in the section with the numbers changed. To do the homework, you need to understand the material, not just be able to repeat some process blindly. Number 2, how is precalculus different from Math 107? This class is faster and covers more stuff. If you barely passed 107, this course may be a struggle for you. Be prepared to spend lots of extra time in addition to the normal time, at least 10 hours per week, required to succeed in a demanding math course, filling in gaps in your mathematical background. There are 2 basic options to get to calculus, 107 to 108 to 201. So let's be clear about all these numbers here. 107 is our college algebra class. I'm sure many of you came from that class. 108 is this precalculus class, and 201 is Calc 1. And 201 is geared towards students majoring in engineering, math, computer science, and the physical sciences, biochem, and physics. An alternative to that track, in fact, a faster way to get to a calculus class, is 107, still college algebra, and then 151, which is our applied calculus class. And if you want to take that 151, you don't need the 108. You don't take this class. You just go directly from the college algebra to the applied calculus class. 151 is intended for students majoring in business or the social sciences, psychology, sociology. Make sure you are in the right track and contact me or your advisor today, or very soon at least, if you have any questions about this. We want to make sure that everybody's in the right class. This class is right for some and not for others, so let's make sure that you are in the right place. Number 3, let's spend a few minutes looking at some highlights from the syllabus. There's a lot of info there. You should read through it in detail over the next few days. So the syllabus is also available up on our Moodle page. You'll find it up towards the top inside of, right there, syllabus. So here it is. I'm not going to start at the very top because at the top of this document is my home phone number and I don't want to broadcast that on YouTube, but feel free to call me at home if you have this document in your hand. So there's lots of good information here. We are going to barely scratch the surface on it, but you'll find my office and studio hours. Very important information about the textbook and materials. So read through all of that. You'll need to follow this process to sign on to our Wiley Plus homework system. There's the catalog description. Here's a list of math department goals and then specific Math 108 goals. Here are my expectations for how this class is going to work. Here's what I expect you guys to do from a day-to-day basis. Here's a list of resources available to you. And here's a list of the things that you will be graded on throughout the semester. Makeup policy, here are the percentages for your grade. And then finally, the the syllabus calendar, which I mentioned before. Okay, number 4. We first start with a review of some of the basics of functions. What is a function? It's a rule that takes certain numbers as inputs and assigns to each a definite output number. And I'm going to write something else here. I'm going to write that it assigns it a single output number, one and only one output number. We call the input the independent variable and the output the dependent variable. Our notation, y equals f parentheses x. We read that, let's write that down too. We read this y equals f of x. So y equals f of x means x is the independent variable, y is the dependent variable, f is the name of the function that relates x to y. Number 5. Suppose f of x represents the value of a car in thousands of dollars, x years after it's purchased. Part A, what does the independent variable represent? B, what does the dependent variable represent? And C, what does the equation f of 5 equals 6 mean? And then there's another question down here in part D. So again, pause the video, answer all of those parts, and come back when you're done. Okay, so if you're back, hopefully you paused the video and thought about the answers to these questions. Again, I encourage you to pause the video when I suggest you do and actually work through these problems as best you can. Embrace the struggle. Part A, what does the independent variable represent? So independent variable is the input, and the input is time. Independent variables almost always x, if there's an x in the problem. So time since purchase is independent. The dependent variable is the value of the car that's measured in thousands of dollars. The equation f of 5 equals 6. The 5 is the input. That's how many years since the car was purchased. So 5 years after the car was purchased, the value of the car, that's the output variable now, that's the 6. The value of the car is 6? No, the value of the car is $6,000. So when we're going to write these interpretation sentences, we want to make sure that they are understandable to a general audience. They really shouldn't have math speak in them. Part D, a car is initially worth $15,000. We're going to translate that to an equation. So initially for the car, that means the independent variable is 0, that's there. Then it's initially worth 15 grand. So we don't put 15,000 here, and we don't even put a dollar sign there. We just put 15. The thousands of dollars part is buried inside of the definition of this function. Okay, next part, the car becomes worthless after 20 years. So 20 years, that's the input variable, it's there. Worthless, the value must be 0. When you're ready, we go to the next page. Part E, of the 3 graphs shown at right, which one seems most realistic and why? So we're supposed to be looking at the graphs of the value of the car as time passes. So pause the video here, analyze these 3 graphs, and decide which one you think is most realistic and why. Okay, let's see how we did. I'll first start with graph A. Graph A, in fact, all 3 graphs actually start up here at 15. The car is initially worth $15,000. That makes sense. All the graphs end over here at 20. After 20 years, the value of the car is nothing. The car is worthless. But the question is, how do we get from being worth $15,000 to being worth nothing in 20 years? So if we follow curve A, you can see that the curve in the beginning, it decreases fairly slowly, and then it decreases faster, and then decreases faster still. For part B, the value of the car is decreasing steadily at a constant rate the whole time. For graph C, the car decreases in value very quickly in the beginning, still decreasing here but not as fast, still decreasing here but not as fast. So which one is most reasonable? Well, a lot of folks know that the moment you drive the car off the lot, it becomes worth a lot less, and it depreciates in value quickly in the beginning and then more slowly in the end. So graph C. Number 6, are all relationships between numbers functions? Suppose that a to the 4th plus 3b is equal to 17. So to be a function means for each input, there is a single output. So let's suppose that, for example, our input is a, and our output is therefore b. It's kind of an arbitrary choice, and we'll make the other choice momentarily. But I'm just going to pick a number. Suppose that I say, okay, what if a is equal to 2? So if you plug a equals 2 into the equation, I just made up a equals 2, but let's plug it in here. 2 to the 4th plus 3b is 17. 2 to the fourth is 16, plus 3b is 17. Do a little bit of algebra there and get b is equal to a third. So if you input a equals 2, the output is b equals 1/3. The question is there any way somebody could have gotten any number other than 1/3? And the answer is no, not unless they made a mistake. So this is a function because no matter what a value you plug in, you go through the algebra, you solve for b, and you will get a single b value every time. So we'll write that as our conclusion here. Let's see. So we would say that b is a function of a, since for each a value, there is a single corresponding value of b. But let's take a look at the other direction. Suppose now that we decide that we want our input to be b, and I'll make up a number. Let's say b equals 1. And that means that the output is a, and let's go ahead and do some algebra to find what value of a we get. So we'll write our equation again here now. So we're plugging in, let's see, b is equal to 1. So a to the fourth plus 3 times 1 is equal to b. So a to the, no, something is wrong, equal to 17. So a to the fourth plus 3 is 17. A to the fourth is 14. And then take the fourth root of both sides, and we get fourth root of 14. No problem. So it would appear that the same thing happened as before, where in this case you plug in, you pick a value of b, and everybody in the world will get one and only one corresponding value of a. But this isn't quite right, and maybe some of you caught it. When we take the fourth root of both sides of an equation, we need to do something special, something that's unfortunately forgettable. We need to put in a plus or minus. Anytime you take an even root of both sides of an equation, you're obligated to put in that plus or minus. So on the one hand, somebody could have said, oh, if b is 1, then a is equal to the square root of the fourth root of 14. But a different person could say, wait a minute. If b is 1, then I get a as the negative fourth root of 14. And that's a problem. And so in this case, looking at our work from down here, we see that the value of a is either the fourth root of 14 or negative fourth root of 14. And that means that a is not a function of b. Since a single value of a, since a single value of b led to two different values of a. So a is not a function of b. Moving on to number 7, we've seen a few of the 4 common ways to write a function. We'll see all 4 listed. I think it's on the next page. We've seen a formula. That's the one we just did here. We saw a graph right up above of the car depreciating. Here's a function represented numerically. Numerically just means with a table of values. So here's a table of values. The first row, I'm telling you the values of t, and in the bottom row, I'm telling you the corresponding values of d. Just a little quick hint here. The first row is always the independent, and the second row is always the dependent. Likewise, if it's in columns, first column is independent, second column is dependent. Part A, is d a function of t, and then part B is the other direction. So we really have to know our word function to answer this question. So to say that d is a function of t means for every given t value, we're looking for one and only one value of d. So let's see, if t is equal to 0, is there just a single number down here? Yeah, And if t is 1, there's a single number. And if t is 2, and if t is 3, and if t is 4. I'm not bothered by the fact that these are the same number down here. All it means to say that something's a function means that for a single input, there is a single output. And that's the case here. So the answer to part A is yes. Each input has one and only one output. Going the other direction, is t a function of d? So here we're looking for values of d and asking if there's single values output for t. So let's take a look. If d is 80, how much is t? Well, it's 0. But over here, if d is 80, how much is t? It's 4. That's a problem. So we can say down here, no, t is not a function of d. If d is 80, then on the one hand, t was 0. But on the other hand, t could just as well be 4. One single input, 80, led to two different outputs, 0 and 4. So t is not a function of d. Part 8. Here's the algebraic formula for the function represented in that table. It's squeezed in here now, but it says d equals f of t equals negative 16 t squared plus 64 t plus 80. So that function right there is how I got the numbers in this table. So for example, if you plug in 0 for t, 0 for that t, 0 for that t, what do we get for the whole thing? Well, it's 80, and that's this 80 right here. Okay, continuing on, it says find the intercepts of this function and explain what they mean in the context of the problem. So pause the video here, see if you can refresh your memory about what intercepts are, how we find them, and how we interpret them. So pause the video and see if you can work through number 8. Okay, let's see how we did. I realize actually that there's no context to be had here because I didn't say anything about what this function might represent. So let's pause on the context part of this problem until we think about maybe what the function might represent, and then we can come back. But sorry about that context thing. Okay, d-intercepts. To find the d-intercepts, you let the other variable equal 0. So we'll let t equal 0. So it's this equation right here, but instead of all of these t's, we're putting 0. So you can see them there. D is over here. Plug in, we get 80. So that means the d-intercept is at 80, but I generally like to talk about my intercepts having two coordinates. So I said the d-intercept is 0, 80. How come 0? Because that's what we plugged in. 0 for t, 80 for d. And why did I put them in that order? 0, 80 instead of 80, 0. Well, up here in green in the table there, it says that the independent variable is the top row, and the independent variable comes first. So t is very natural to put first, d is very natural to put second. Okay, finding the t-intercepts is quite a bit more complicated. The process is the same. Let the other variable equal 0. So we'll let d equal 0 in this equation. So this becomes 0, and then we copy all of that. We've done that there. And now the goal is to solve this equation. It's a lot harder to do. So it is a quadratic equation because that power up there is 2. And you could solve any quadratic equation you want by using the quadratic formula. So if you tried that, it should hopefully have gotten you to the right answer. If you did everything correctly, then you'll get the right answer with the quadratic formula. If you didn't try that, then this might be a good time to practice the quadratic formula and make sure that you get the right answer. In this case, we can try factoring because 16 happens to go into all three of those numbers. So I pulled negative 16 out because I like my t squared to have a positive coefficient. So factor that negative 16 out and we get this. And then that thing here in the parentheses is pretty easy to factor. So make sure you can factor stuff like that. And then we've got this 0 product idea where one of these pieces must equal 0. So either t minus 5 is 0 or t plus 1 is 0 or negative 16 is 0, which it isn't. So we didn't bother writing it. So we get t is 5 and t is negative 1. So the t-intercepts are 5 and 0. 0 because we started with letting d equal 0. And negative 1, 0. So those are the two t-intercepts. Just one note here. Actually, we'll come back to, there's a web page I'm going to show you, but let me do that after number 9. So number 9 says graph the function from above. So you've got lots of points that you're going to plot to graph this function. We've got all the points in the table here, and then we actually have a few more points because you just found some intercepts. So pause the video, see if you can come up with a reasonably accurate graph, and squeeze it in there in number 9, and come back when you're done. Okay, so I've drawn my axes here on the left. Try to be accurate when you draw these things. It's okay to have different scales. You can see that the scale on the t-axis here, the independent variable axis, is such that this is a unit of 1, but here that's a unit of 50. So it's definitely not the same scale. But pick numbers so that you can try to get all the important points from the table and these intercepts to show up on your graph. So you can see I went up to 150 there because the table biggest d value is 144. And then make sure you get out to at least 5 and -1. And so I've plotted the points from the table. Those are the ones in purple. I also plotted the d-intercept, that's here at 0, 80. And I plotted the 2 t-intercepts in green. We found them over here also in green. And so we get this kind of a graph, and probably you're guessing, or probably you've seen this kind of a graph before, so we'll connect the dots and just draw something that is curvy. Make sure you don't just try to connect with straight line, straight line, straight line, straight line. Don't do that, but rather draw something curvy. So we'll draw a curvy thing and try to get close to points. Now, in theory, this thing probably continues on just like it does here. But now we can think about, well, first, what's the name of this kind of a graph? So hopefully you've seen this before, but because this is a t-squared, the name of the graph is a parabola. We'll have a lot to say about parabolas later on this semester. So moving on to, okay, so before we move to 10, let me just show you this website. So if you Google Wolfram Alpha right there, or just go to wolframalpha.com, then it brings you to this page. It's a wonderful resource. So let's try typing this in. D equals -16 t to the second plus 64t plus 80. So we've got our function typed in there. We'll hit enter and just see what it says. So Wolfram Alpha is this computational engine. And what is it telling me here? Okay, it's a parabola. It's showing me the graph right there. It's showing me another graph here. What's going on? Let's see. This graph is from -1 to 1. That's interesting. Those were the 2 t-intercepts that we found were pretty important. This graph is t equals -20 to 20. And so this is a really zoomed out graph, so you can see what's going on. This part is the only thing that we drew, but really that's just a very tiny part. It's right up here at the top. It's just that little sliver of a much larger graph. Alternate forms, there's a factored form. We wrote down -16 times t minus 5 times t plus 1. And it gives you some other stuff. There's, let's see, integer solutions. Okay, I'm not sure what that means. You can solve for the variable t and get that. And then implicit derivatives, domain, range, some stuff that you've seen, some stuff you haven't seen. Other thing to do is if we wanted to just say, okay, I want to know what you get when you solve 0 equals that thing. So we knew we were going to get t equals 5 and t equals -1, but what if we didn't know that going into it? You can see, come down here, it just tells you what the solutions are. So a really nice resource, wolframalpha.com. Okay, number 10. What might the function above represent? Be as specific as you can. So you've got this graph in front of you, and the question is, have you seen anything with your own eyes, some actual thing that behaves like this graph is illustrating? So pause the video, see if you can come up with some specific example of something that might behave like this graph. Okay, and I'm sure there are lots of right answers. The one that pops into my mind is that of a falling object. So if you take, let's say we start the clock here at t equals 0, and we take a ball and we throw it up, and eventually it reaches some maximum height, and then it comes down and eventually reaches the ground. And so, so this is a kind of standard looking thing for a falling object problem. So it could be the height of a ball that is thrown upwards. And so now if we think about the question that I asked earlier but that question didn't make sense earlier, is what did the intercepts mean in the context of the problem? What do the intercepts mean in the context of the problem? So we had 0, 80, which is this point right here, and then we had 5, 0, and negative 1, 0, these 2 points in green. So pause the video, see if you can write down some sentences. These should not be math sentences. They should be sentences written in plain English that describe what those 3 points have to do with the context of this problem. Okay, so I've written my contextual answers here. The point 0, 80 says that the ball is initially is the time t equals 0 part, initially thrown from a height of 80 feet. So maybe you're standing on top of a building that's 80 feet tall. 5, 0 says the ball hits the ground because it is 0 feet off of the ground. Ball hits the ground after 5 seconds. And then negative 1, 0 would seem to be another place, another moment in time when the ball hits the ground, but that moment in time is negative 1 second, which doesn't really have any meaning in the context of the problem. Now, that said, you probably could give some meaning. It's going to be a little bit, it's going to feel a little bit made up, but I guess what you could say is that instead of you standing up there at the top of the building, throwing the ball and then having it go up and then come down and land 5 seconds later, you could have a friend who is standing on the ground right over here, and the friend throws the ball up, and the ball takes 1 second to get to you. Now, you're not going to catch it. You're just going to watch it. It's going to shoot right past you as if you had thrown it up. And then it's going to land 5 seconds later from the time that it passed you, but it's really been 6 seconds in the air since your buddy threw it up there. So not really a meaning, but I guess you could kind of add one to the problem if you wanted to. When you're ready, next page, number 11. Here are the 4 basic ways to represent a function. Identify each of them in the preceding example. Algebraically with a formula, numerically in a table, graphically in a graph, and verbally with a description. Okay, so let's run through these. Algebraically with a formula, so we saw the formula here. The formula that we saw was this negative 16t squared business. And then numerically means in a table, so I'm not going to fill it all in, but we had this table on the previous page that had all of these numbers in it. So that's the numerical way to represent this function. Graphically, so that was the one that we just sketched. That was our friend the parabola. So that's number 3, blue for number 2, and then purple for 1. Okay, and then finally, number 4, verbally, was the context that we made up for this problem. So in this case, we said height of a ball that is thrown upwards. So 4 different ways, and those are the 4 standard ways to represent a function. Number 12, let's have a look at the learning objectives below. We're going to have a really detailed look, actually, at all the stuff that's on the rest of this page. I'm not normally going to do this at the end of many of our videos, but just in the beginning of the semester, I want to make it really clear what all of this stuff down here means until we get into our rhythm. It's crucial that you spend as much time as you need going through the material at the start of this course, as we'll be going through the review material very quickly. Okay. Learning objectives after class number 1. That 1 means something. That 1 is the same one that we saw on the very first page. We start with class number 1, and then at the end of the day, it says learning objectives after class number 1. And I also want to point out that that number 1 is the same number 1 that we saw right here. Oops. It's the same number 1 that we saw right there. Class number 1. And so the next class that we're going to do will be numbered class number 2. So if you are lost, just take a look at that number right there. It gives you information. Okay, your homework is first to read sections 1.1 and 2.1. Those are the sections that we covered today. They are in your textbook. On Wiley Plus, you're going to do the assignment titled Homework 1. So you're going to log into Wiley Plus. There's information about how to do that in the syllabus. So go through there, log into Wiley Plus. If you have any trouble logging into Wiley Plus, please contact them and contact me. We want to make sure that everybody gets into this class as soon as possible. And you're going to go through and you're going to do the homework. Homework number 1, it's this one right here that matches that one. You'll see a lot of homework assignments in Wiley Plus. You want to make sure you're doing the one that has the same number as the learning objectives. Okay, this section right here says after attending class, doing the homework problems, and getting help as necessary, you should be able to, and then there's a list of things I'd like you to be able to do. Now, it's okay if you can't do all 5 of these comfortably right now, but you're going to do a lot of work between now and the next class, and you're going to get to a place where you feel comfortable doing all 5 of these things. And so I think that some students just choose to ignore all of this, and I think those students are missing an opportunity. I like to look at this as a checklist. If you know how to recognize a function defined graphically, numerically, verbally, or by an equation, put a check next to it. You can do that. If make and interpret statements using function notation is questionable to you, then that's something you'll need to work on. So I'd encourage you to take a look at that list every day. Okay, next part, class preparation. In order to prepare, so this is kind of now the stuff that we've done already and you're going to work on. This is the stuff that you're going to do to prepare for the next class. You're going to review the prerequisite concepts and formulas reference sheet. You'll find it on Moodle. And then you're going to read from your textbook these 4 sections right here. This is reading ahead. Here's the reading for the sections that we just covered today. Here's the reading ahead. Normally, we're not going to have read 4 sections. I think our normal assignment here is only going to be read 1, but there's a lot of review stuff to do at the beginning, so a little bit more reading is put on your shoulders at the start of this term. Next thing, questions of the day. Answer the following questions and email me. There's my email address. Your answers by the beginning of class. In the subject line of your email, please, please, please put QOTD, standing for questions of the day, and put the class number. Class number here is 1, and your last name. So for example, you can email me with the subject line of QOTD 15 if it's class number 15, which it isn't, and then your last name, Smith, or whatever it happens to be. So you're going to answer these questions and put them in an email to me with that subject line. So number 1 is asking you to tell me a little bit about yourself. Number 2 is asking you to identify something about linear functions. 3 is about exponential functions. You will find answers to these questions inside of the reading. So do the reading, and hopefully after doing the reading, you can answer these questions. Email them to me. They are due by the beginning of next class, which is usually a couple of days away. Okay, and then always this is going to be here. Do you have any questions about the reading? If you do, I want to know. Okay, and then sometimes we're going to have another section in this learning objectives list. So learning objectives is all of this. Normally it's homework, then the list of skills, then the class preparation, then the questions of the day. But sometimes there are going to be other things to do, and in particular here at the start of the semester, there are a few other things to do. So you're going to read the course syllabus. Again, you'll find that on Moodle. Make note of any questions that you have and ask me about them soon. If you haven't already, you're going to buy a Wiley Plus access code. You'll find info on this in the syllabus. If you don't have one already, buy or rent a graphing calculator. We recommend the 83 or 83 plus or 84 or 84 plus. There's information about that in the syllabus. There are plenty of calculators that are great but not usable by you on tests and quizzes. So if you have a calculator other than one of these 4, please email me and let me know what you have, and we will decide if your calculator is appropriate. And next thing is, of course, you're going to visit the Moodle site. Maybe you've already done so. And if you can't visit the Moodle site, if you're not able to, there's some good information at that site right there. Okay, and so we're just about ready to call it a day for class 1, but I do want to point out that, let's see, so you have access to a blank Word or PDF document of all these materials here. Hopefully you've had that in front of you and been filling it in. But I also want to say that I'm going to, right after class, make a PDF of the filled in version with all of my notes written in here, everything in color just as you see it. And I want to show you where that's going to be located. So again, it's on our Moodle page. Scrolling down to the materials for the first test, you'll be in this box for a while. Right there, filled in copy of class notes for the first test. So if you click on that, open up the PDF, you will find exactly this thing in exactly this form. Okay, so hopefully this was a good first class video for you. If you have any questions or comments or any of that, please send me an email, and hopefully things will go well starting from the start of the term for you.